at 4 seconds. This is at t equals 4 seconds. And then the bolt hits the ground at t equals 6 seconds. Now, when the bolt comes off the rocket, it's got a velocity initially going up because the rocket was going up. But once it detaches from the rocket, its acceleration is acceleration due to gravity, minus 9.80 meters per second squared. And it takes it 2 seconds to hit the ground. What we want to know is what the acceleration of the rocket is. So we're going to have to work backwards. First, I'm going to have to figure out what the initial velocity of the bolt was when it started falling off the rocket. Okay? And I do not know what the velocity final is here. I don't know velocity initially, I don't know velocity final. All right? You can't say the velocity final is 0 here because it's not at 0 velocity when it hits the ground. Okay? And I don't know what this y is. I'll call this y1. Down here I've got y equals 0. Okay? So make sure I got all the components on that problem. No, it hits the ground 6 seconds like your shoes. This is at 10 seconds. I was about to say that looked pretty slow. So that's all the information we've got. Okay, so let's start working on things. Well, I know that, let's see, V final here would equal V initial plus AY delta T. And I don't know either one of those. I do know the acceleration. I know delta T is 6, but that doesn't do me a whole hell of a lot of good. I would have V final equals V initial minus 9.80 meters per second squared, and I've got 6 seconds. I've got one equation and 2 unknowns. I know that Y final equals Y initial plus V initial delta T plus 1/2 AY delta T squared. So I've got 0 equals Y initial plus V initial times 6 seconds plus 1/2 times a minus 9.80 meters per second squared delta T squared. Now, let's look over here on the other side. This is Y1, so Y initial is Y1. Okay? So, and this is that V initial for over there is the velocity here. Well, I know that Y1 is equal to the V initial here, which is, Y initial here is 0. I'll call this Y1. Okay? Y1 is going to equal 0 plus 0 delta T plus 1/2 the acceleration of the rocket times 4 seconds squared. So I have Y1 is equal to 1/2 AR times 4 times 4, 16 seconds squared. Okay, this gives me something that I can work with. Okay? So I'm going to bring that over here. I'm going to say 0 is equal to 8 seconds squared times AR, acceleration of the rocket, plus velocity initial plus 1/2 times a minus 9.80 meters per second squared times 6 seconds squared. Okay, now I'm down to 2 unknowns and 1 equation. And over here, I can say that velocity initially is equal to 0 plus AR times 4 seconds. So I'm going to sub that in. So I have 8 seconds squared times AR plus AR times 4 seconds plus 1/2 times 9.8 times, let's see, 0.8 times 2, let's see, 9.8 divided by 2 times 6 squared minus 176.4, that should be meters. Second squared times acceleration, that should be meters. Let's see. AR, V was the initial, T. So the initial, that should be delta T there, times 6 seconds. Whew, I almost made a mistake. Remember here I've got V delta T, that should have been V delta T. So 4 times 6, that's 24. So I have 0 is equal to 8 seconds squared AR plus 4 times 6, that's 24 seconds squared AR minus 176.4 meters. So I take that over, I get 176.4 meters is equal to 24 plus 8. That would be 32 seconds squared times AR. And I divide through. And I get the acceleration of the rocket to be 5.51 meters per second squared. Now, it makes sense that I got an acceleration for the rocket going up smaller than acceleration due to gravity, because it took more time to get up than it took time to get down, and it was moving up in the beginning anyway. Now guys, the reason I like this problem is because you have to start building systems of equations by looking at what you've got and start looking at plugging in holes. So I want you to try this equation on your own, this problem on your own, and come back and look at it and compare against what I've done. Okay? How am I doing on time? Just about where I want to quit. All right, guys, that's where I'm going to stop. We've only got one little piece of something to finish off chapter 2, so we're doing real well.